Okay, I want to show you what an imaginary number is. They come actually from square roots. So I'm going to write something down, the square root of 4. Okay, and so we know that the square root of 4 is 2, and the reason is because 2 times 2 is 4. That's how we know the square root of 4 is 2. Okay, but what about the square root of negative 4? Well, you've always been told that you can't take the square root of a negative number, because what number would you multiply by itself to get a negative number? Okay, it can't be done. This is where imaginary numbers come into play. So imaginary numbers by definition are of the form b times I. And I'm going to connect this to square roots in just a second. So b is the real number part. So I'm going to put real. And this is the imaginary unit. The imaginary unit. Okay. So I, by definition, is the square root of negative 1. So when we look at something like the square root of negative 4, which I'll write again over here, okay, even though there is no real number answer, there is an imaginary answer. So let's break this apart. The square root of negative 4 can be broken apart as the square root of 4 times the square root of negative 1. So all we did was we just broke 4 apart as 4 times negative 1, and you can separate the two radicals like this. So the square root of 4, that we do know, the square root of 4 is 2. And the square root of negative 1, well, by definition, that's I. So the square root of negative 4 is 2I. Let's try another example. Let's do 5 times the square root of negative 48. Okay, so what we want to do is we have a few things going on here. We're taking the square root of a negative number, so we know I is going to be involved. But we also have the square root of 48. Okay, the square root of 48 is not a perfect square, so it doesn't have a square root. But it does have a factor that's a square root. So I'm going to break this apart as follows. So this will be 5 times the square root of negative 1. Okay, so I'm going to break negative 48 apart as negative 1 times, now I know that 48 is 16 times 3. And 16 is a perfect square. In fact, it's the largest perfect square factor of 48, which is exactly what we want to simplify the radical. All right, so now that we have it broken apart nicely like this, we can go ahead and simplify. So the 5 gets carried down right here, okay? Nothing happens with the 5 yet. And then the square root of negative 1 is I, so we'll just put I right like that. Okay? And then the square root of 16, well, that's 4. Okay? And then the square root of 3 is just the square root of 3. We can't do anything with that. Now we can simplify. We have the 5 and the 4 here. Okay, that's going to be 20. So 5 times 4 is 20. I'll put that in front here. 20i square root of 3.